Welcome to Chapter 19, Section 1. We're going to be talking about magnets and magnetic fields. So what we're going to do today is we're going to predict whether magnets will attract or repel for given situations. We're going to describe the magnetic field around a permanent magnet, and we're going to describe the orientation of Earth's magnetic field. So I'm really sure most of you are familiar with basic magnets, either as a toy and something you played with, or to hold items onto your refrigerator or magnetic board. So we're going to look at several unique characteristics of magnets, okay? So for one, they attract all iron-containing items, right? So this one here, it's strong enough that even through this person's hand, it can attract these paper clips because paper clips have iron in them. So magnets have several unique characteristics, okay? They have poles, okay, which are opposite ends that act differently, and we call these north and south. So you can see it here, we've got a bar magnet that's been labeled north and south. So magnetic poles are similar to charges by the characteristic that like poles repel each other and unlike poles attract each other. Okay, so for example, if you had two north ends of a pole next to each other, right, they would be forced apart. Okay, but if you had a north and a south pole, they would be attracted. So we can see this here on this next slide, that they're showing you all the different possibilities, okay? So you can't have a monopole, so you can never have just a north pole. That's not possible. So that's why all of these have north and south. So if you put the north and south ends together, they attract. If you flip that, which one it is, they attract. North and north together, they repel each other, and south, they repel each other. So these arrows all represent the force either pulling them together or apart. So magnets are important for a lot of areas of technology, okay, and this is why we study them. So compasses were the very first technology to use magnets, okay, this is also the most basic technology, and it was just to tell where north is. So they were first used by the Chinese almost 2,200 years ago. Magnets are also important in other things, okay? Today, maglev trains, like the Taiwan's HSR and the ones in Japan and other places, those use magnets to propel them, okay? And they have this interesting little system to help keep them on the magnets. But that's how they're able to go so fast. Magnets are also used in like credit cards and debit cards or bank cards, okay? And also things like your Easy card for the MRT. Those are also examples of an application of magnets. And really there are hundreds, if not thousands, of other everyday applications of magnets. So as we talk about magnets, the next thing we need to look at is what is a magnetic field. Okay, so a magnetic field is just a region in which a magnetic force can be detected. So all these little shavings are called iron filings. Okay, they're just tiny pieces of iron. Okay, and if you put them around a magnet, you can see this pattern emerge. And this is our magnetic field. You can also see it here. There's a compass that lines up with the magnetic field too. So this would be it if it was under a piece of paper you could see. Okay, so we've got kind of, it actually reminds us of the charge between a positive and a negative, right? This is kind of what the field looked like when we would do that. It's very similar, okay? So it's another way that magnets are similar to electric charges. Okay. So you need to know a few things about magnetic fields, okay? So the number of magnetic field lines through a surface, okay, is what we call magnetic flux, okay? And the number is proportional to the strength of the magnetic field, okay? So flux is proportional to the magnetic field. B is the letter we use for magnetic field. Okay, let's look at this and maybe draw some field lines, okay? So when we draw field lines, they always go from north, okay, and they point to the south. It's really the only thing other than more lines equals stronger, okay? Those are our really two keys. So if we start here, the nice thing about this one is we can kind of just follow the pattern created by these iron filings, and that's how it should look, okay? That's kind of hard to see, isn't it? Let's see if we can fix that. So yeah, in this case you can just kind of trace the lines we see, but you would draw it the same way even if you couldn't see these lines, okay? So you always start at the north here and go towards the south. Okay, so here's an example of one already drawn, and I just want to point out a couple things, okay? If we take a look at it, all right, and we look at how thick the lines are, notice that the lines are stronger in this box than if I draw a box the same size here, okay? So that means that the magnetic field here is stronger because it has more lines than the magnetic field here, okay? So, and this just has to do with the fact that the pole is here, and so is there, and here we're in between them, okay? So that's how we work on drawing magnetic field lines. So, magnetism is everywhere, and I just want to point out a few of the places where you might be surprised to find it. So, one thing is that there's something called magnetic domains, okay? So each atom in a magnet material acts like a magnet. Every atom. And we're going to learn why later, okay? But what happens is you get all these are the direction of the magnetic field. So this end would be north and this end would be south, okay? And in things that are magnetized, these all point the same direction, okay? But if it's a material that's not magnetized, then the fields point all different directions and the fields don't line up. Okay, so all the fields need to line up, okay, in order for the whole thing to be a magnet. Okay, so ferromagnetic materials, the magnetic fields line up, okay, and materials like iron, cobalt, and nickel are like this, which means they can be magnets. So, turns out there's also bacteria in magnets in bacteria. Okay, some bacteria, for example, this one called Aquaspirillum, and magneto, you could guess from that, magnetotacticum. Okay, they've been found to orient themselves and move along magnetic field lines, okay, and it's because they have this iron oxide, okay, and please notice this is iron, right? So iron is magnetic. That didn't write very well, sorry about that. Okay, iron is magnetic, and so it allows them to have this crystal inside them act like a compass, and they can travel along the magnetic field line. Okay. Also, the Earth is one big, huge magnet. Okay, the center of the Earth is made of iron. Okay, so Earth's center is iron. Okay, and so that is part of the reason that it has a magnetic field. Okay. And so what happens is you get the magnetic field looks like this. So notice we always talked about how with the lines it comes from the north to the south. Okay, so true north is down here and true south is up here. But our compass points to having the north magnetic pole here and the south pole here. But this is just because the north of the compass magnet points this direction, and so they called that north. Another interesting fact is that Earth's magnetic field has flipped many times. Okay, and our evidence of this, right, is that the bottom of the ocean floor, okay, lava is flowing out. So when it flows out, okay, it cools, and because it has iron in it, the magnetic field points one direction. Okay, so maybe here the magnetic field is pointing this direction, okay? So then it's still pointing this direction here, and this white space in between it had flipped and pointed the other direction. And now it's coming out again, and it's pointing the same way. And the same thing down here, so you get this pattern of this direction, this direction, this direction, this direction, this direction, okay? That you can see on the bottom of the ocean floor, okay? Because of the iron that cools as it is pushed up. So this iron from Earth's crust tells us this story. So that brings us to the end of our introduction to magnets. You'll get a chance to practice some skills like drawing field lines in class, and I will see you there.